Hi, and welcome back to Algebra 1. Our goal for today is to continue working with our linear equations and forming a picture version of the graph of all the solutions. At this point, we should fully understand that there are many different forms or ways that a linear relationship can be presented. Proportional relationship form, slope-intercept form, point-slope form, standard form, function notation form, and then we have these special case lines that only have a variable x or only have a variable y. We can tell that these all represent relationships that would form a line when we go to graph the solutions because the degree on our x term is a 1. Now, if I had something that looked like this, y equals ax squared plus bx plus c, which sort of looks like standard form, but our highest degree here is a 2. That's no longer a linear relationship, and that's now what's called a quadratic. So what we're looking at is I have a relationship that is described in equation form that would form a line. We should understand that we could create a table of values of some of the locations on that line to help us graph that line. Now, we've been doing 4 solutions on our line to help us connect and draw our line as straight and as accurately as possible. Because if we only did like 2 of these, right, it would still form that same line, but we might have a mistake somewhere. We wouldn't catch it, right? So I've been asking that you find 4 locations on your line to help you draw a more accurate line. And then we looked at our special case lines that are perfectly horizontal and perfectly vertical. These are our lines that only have x's and y's. When there's only an x in our equation, our first step would be to solve for x. Once we know that letter, we know that entire row or column of our table, depending on how our table values is facing. And then our other variable can be anything. We've been using -1, 0, 1, and 2, but again, they could be anything, any numbers. I would pick between -10 and 10 so you don't have to renumber. And when we have an x equals line like this, we'll have a line that looks like this, which is vertical. It will always have what's called undefined slope, like we're falling off that cliff. And then we also have our y equals line, right? In this equation, we only have a variable of y, so we want to solve for that first. Once we get here to y equals something, that means we know our entire output, which is our y part of our table. This column of x can be any number. Again, we've been using -1, 0, 1, and 2, but it could be anything. And we'll end up with a line that looks like this, which is called horizontal, which means we have what's called 0 slope, right? We're on top of the mountain. So our goal for today is, instead of using a table that has 4 solutions in it, can we make a sort of abbreviated or shorter table just using these 2 specific spots, our x and our y intercepts? Remember, our x and y intercepts are places where our line cross our x and y axis. So as long as we have those 2 spots, so for this particular line, right, here would be our y intercept, here would be our x intercept. As long as we have those 2 points, we could technically draw our line. Now, keep in mind, I've been asking you to do 4 so that hopefully if we make a mistake, we would catch it. Or, you know, we can pick our x's so we land at perfect y locations that are easy to graph. Our x and y intercepts might not always be at perfect locations. So there's some advantages to using just the x and y intercept, which is we only have to solve for 2 points, which makes it a little bit quicker and easier. The disadvantages of using the x and y intercept is they might not land at perfect locations, which makes them a little bit trickier to graph. And if I mess up one of the 2 intercepts, I'm still going to have a straight line, so I'm not going to necessarily know that I made a little mistake along the way. So let's look at using our intercepts to help us graph. Now, we typically use this method of using x and y intercepts when we're given what's called standard form. And the reason is this standard form is not in that function form of y equals. Now, point slope form is not in y equals format either, but we actually have an easier way than intercepts to graph. So we'll get to that later on using our point slope format. So typically, standard form, finding our x and y intercepts would be considered the easier method of graphing, or the easiest method, because it doesn't require any rearranging. For x and y intercepts, we don't need function form. We don't need to solve for y equals. All we need to do is say, if I put a 0 in here for x, what does the y equal? That would give us our y-intercept. And then I'm going to repeat that process and say, well, if y equals 0, what is my x-intercept, right? So I'm going to substitute in 0 here. And it doesn't require us having to get y equals, which is helpful. So if, for example, I gave you, the equation, linear equation, 4x minus 6y equals negative 36. We want to solve for the x-intercept. Some of us were messing up on this on our module a couple of weeks ago, or assignment a couple of weeks ago. That means I want to solve for x. So down here, I want an x equals, not a y equals, which means I'm not making this x 0, I'm making this y 0. So my problem would look like this. 4, I want to keep x because I want to know what that is. Minus 6 times 0 equals negative 36. Right? The 0 should be going in here for y when we're solving for the x. When I'm trying to solve for the y-intercept down here, I ultimately want y equals, which means up here at the beginning, it's the x that I'm replacing with 0. So just be careful that you're correctly identifying what's my x-intercept and what's my y-intercept. Some of you had the right work, but had these two blocks backwards, which indicates I don't really understand what I'm solving for, so be careful. All right, from here is PEMDAS or inverse operations, whatever we need to do to help us solve the equation for x and y. So over here for 4x minus 6 times 0. 6 times 0 is just 0. So that term it eliminates, right? There's nothing there. And we end up with this 4x equals negative 36. All right, from here, it's a one-stepper where we want to divide both sides by 4. Now be careful, that's a negative 36 being divided by a 4, which would give us a negative 9. Now the other place where some of us messed up was I was asking for our answers as ordered pairs, and some of us stopped there. Right? Remember, ordered pairs always go x, comma, y. Right? So this is my x. It goes first in this ordered pair. So our ordered pair would be negative 9, comma, 0. And we're going to use that as one of our points to help us make our graph, right? We go to the left 9, don't go up or down, plot a point. It's one of our 2 points we can use to help us graph this line, 4x minus 6y equals negative 36. All right, let's get our y-intercept. It would also ultimately eventually help us graph the entire line. So 4 times 0 here is nothing. Now, here's where people mess up. Remember, this sign goes with this term. You can't drop it. It's not 6y. It's negative 6y. And if I say that that's 6y, I'm going to have a mess up. I'm going to get a y. I'm going to plot those 2 points. I'm going to plot my negative 9, comma 0. I'm going to plot what I get over here for y. And it's still going to form a straight line. And I won't catch that I made a mistake because it's still going to ultimately look like a line. So you have to be careful with your signs. From here, we're going to divide both sides by our negative 6. Negative divided by negative here will give us a positive. Now remember, our ordered pairs are x, comma, y. So this goes second in an ordered pair. So this is 0, comma, 6. Not 6, comma, 0. That would give me a second place on the x-axis. So be careful. So our ultimate goal for today is once I have these 2 points, can I create a smaller version of my table, right? Where I have x-intercept, which is this guy, negative 9, comma, 0, and a y-intercept, which is this guy, 0, comma, 6. Then take those 2 points, plot them in the coordinate plane, and draw in the line. All right, so let's go to our note packet, example number 1. I want to graph the linear equation that's given to us in standard form of x plus 2y equals 8. Now remember, for x and y intercepts, we don't need function form. It's one of the advantages. So we can go straight to doing our work. If I want an x-intercept, that means I'm going to get an x equals in the end, which means y is 0. So 2 times 0 equals 8 here. And if we're solving for a y-intercept, that means our x is 0. So 0 plus 2y equals 8. All right, let's do our math. 2 times 0 here goes away. Ooh, x equals 8. That's an easy one. So up here, we have when our y value is 0, right? I already put that in there. Our x is 8. Or remember, that's the order pair 8, comma, 0. All right, let's do the same thing when our x is 0. We have 2y equals 8. All right, this is a one-stepper, so divide both sides by 2. And we'll end up with y equals 4. So our y-intercept would be at 0, 4, right? This is representing the point 0, 4. All right, let's plot and graph. So 8, 0 would be go to the right 8, which is way over here on our x-axis. And 0, 4 would say go up 4. Right, there's our 2 points. Now, if we made a mistake somewhere, we're not going to know it because these are definitely going to connect and form a line when we connect them. Right, so we want to connect, obviously hit all our points, and draw in our line. Now, again, we might have drawn it a little less accurately because we're only using 2 points, but it's giving us a good idea of where our solutions are on that line by only finding the x and y intercepts. All right, let's try another one. Originally presented in standard form. So we're going to use our intercept method here to help us graph. So our this table says input output, but remember that's still x, y always. So our x-intercept, solve for x when y is 0. So x is what I want to know. When y, the other thing is 0, equals 7. Y-intercept, I want y equals in the end. So x is 0. Keep the y a y. I want to solve for it. Now this one's pretty simple. X is then 7 and y equals 7. Right, not too much to do down there as far as solving. So 7, 0 and 0, 7 are our 2 points we can use here to connect and draw in our linear equation. So to the right, 7 would put us way down here. Up 7 would put us up here. Again, if I made a mistake somewhere, I'm not going to know it. Right? It's a downfall of using intercepts because it looks like I have a straight line, right? So again, when we were using multiple points and we ended up with like a little bit of a zigzag, we could use that to help us check to make sure we did our work and our graphing correctly. All right, let's try one more together. Number 3. All right, this one's a little bit more complex, but it's still standard form. So 4x minus 2y equals negative 12. It's in standard form, so a quick, easy method here would be to use our intercepts instead of a full table with 4 values. And now keep in mind, we could still use that other method of solve for y equals and pick out x's and solve for y's. It always works. All right, let's go here. X-intercept. We have 4x. I want to keep x because I'm solving for the x-intercept. Minus 2 times 0 equals negative 12. And then over here for y, I want to keep y. So 4 times 0 minus keep the y and minus 2y equals negative 12. All right, let's solve. Over here, this minus 2 times 0 goes away. We have 4x equals negative 12. All right, one stepper from there. We're going to divide both sides by 4. Cancel on the one side, right? We have x equals, which was our goal, which is what we're missing up here. Negative 12 divided by 4 would just give us a negative 3. So our point here would be at negative 3, 0. All right, let's do our same thing for our y-intercept. 0, where is y? All right, this term's gone. Remember, this sign goes with this term. Don't lose it. Don't drop it. You need it. That's a negative 2y. So we're going to divide both sides by negative 2. If I have a positive 2 there, I'm going to get a y. It's going to look like I did my work correctly. However, it's not going to give me the right y-intercept. And when I go connect, then my line does not actually represent the solutions of this line. So be careful. So y equals 6. So 0, 6 would be our ordered pair. All right, so we're going to go left 3 this time. Up 1, 2, 3, 4, 5, 6 would put us here. And now that we have 2 points, again, if I made a mistake somewhere here, I won't know because it looks like a line. So I'm going to take my ruler, straight edge of some sort, connect, draw in. Remember, my line should stretch the entire distance of the coordinate plane and have arrows on the end. If I'm working on a Google slide, I have to change the ends of my segments. It's a setting up in your toolbar from being just a flat to an arrow to show that this is a line, not a segment. So make sure you're always doing that. All right, on your own, you try your last 2. 4 and 5, you have the standard form of line. 5x plus y equals 5, and 3x minus 2y equals negative 6. Go ahead and try those. Hit pause here on the video. All right, hopefully you've finished your last 2. Let's look at them. All right, so 5x plus y equals 5 has an x-intercept of 1, 0. and a y-intercept of 0, 5. We plot, we connect, we'd end up with a line that goes up, has a point that goes up 5 and a point that went to the right 1. All right, 3x minus 2y equals -6 has an x-intercept of -2, 0 and a y-intercept of 0, 3, which means our x-intercept will go to the left 2, our y-intercept up 3, and then we can connect to draw the entire linear relationship. All right, this should help you. This video should help you complete your assignments. Have a good one.